Good afternoon to everybody. We are very happy, Christian and myself, to have this possibility and this big chance to be there today to speak about continuous delivery. And we will cover many, let's say, technology, new technology aspect. So take the time to hear what we will present about this technology.
Yep. And if you guys don't mind, before we start, can you guys move up? Can everybody move up and move in? It's like Swiss cheese out there. Thank you. Thank you. Okay. So we'll get started. We're going to be talking about, we're going to be focusing on the topics of continuous integration and continuous delivery. And we're going to be using some existing tools, some product stuff, and some community stuff. And it'll all be related to integration and Fuse in some way, and we'll point that out. So I'm Christian Posta. I work for Red Hat. I also participate in the open source communities. I came over from consulting, so I've worked with some of you and actually implemented Fuse in a meaningful way. And Mr. Chow?
I'm Michel Moulliard. I am also, like Christian, an Apache committer on Camel project, Karaf, and many more. I'm also working for Red Hat as a consultant. I am part of a different team today, and I work also to prepare some course delivery for maybe some of you or for new incoming customer. I am a technology evangelist and enjoy to do mountain bike. And beer. Excellent Belgian beer.
Did it say beer?
So
it does. Nice.
Oh, yes. So here is the list of the points that we will cover today. The reason why we would like to speak about the continuous delivery, continuous integration, there is an evidence, cost of a change. And this is what Christian will start to introduce at the beginning. After that, we will explain that to reduce this cost of the change, you have to put in place a strategy to have something to continuous monitor, let's say continuous build, release, publish something, test, promote something, everything like that. So we will introduce also some new technology key concept because they have been packaged into OpenShift version 3. So we'll take the time, let's say, to introduce why we are using this technology and what it will offer today and tomorrow for you when you will put in place your strategy for continuous delivery and continuous integration stuff. And for sure, at the end, we will finish with the Fabricate technology, which is an open source, but in fact a project which has been merged with OpenShift. And we will make a great demo about what this technology offers, which is a kind of one-click technology, because we will start to create a project from scratch, creating different Git repository, publishing the code, and after that you will see what we are able to do with this technology.
Okay, so I'll really quickly level set and just give some context to why we even care about continuous delivery, continuous integration, and all that. I'm not going to talk too much on that because I want to get to the demo and I want to see it work too. So as developers, we, at least from my point of view, I get caught up in this. We get so focused on the technology, all this new stuff, Camel's awesome, Kubernetes, and all this cool stuff. And we forget that the reason we're doing any of this stuff is so that our employers who are paying our salaries, investing in us, make money or save money, deliver value that ultimately keeps everyone employed. And these companies, they're competing fiercely, and their markets are changing quickly, and they have to adapt. They have to change the way they do business, and small boutique competitors and startups and so forth are taking over their their market. So they have to adapt, they have to change, but to be able to do that, they have to have you have to have in place the ability to change. Right now, the way our organizations are set up is very difficult to do that. So it's very difficult to make a change. How long does it, think about it, how long does it take you to make a change to your code and actually get it into production? Are there any people doing continuous delivery right now? Oh, a couple. Okay.
Yes.
Okay, so part of the cost for making changes is all of your systems, they need to be integrated with each other. And the reason they need to do that is because the business expects those systems to kind of look like one big system and be able to derive and analyze the business at runtime to see how things are actually going. So getting those systems to talk to each other is a really big pain. It's really hard. It's really not fun. And different reasons for that, different vintages of systems, mainframes and Corba and Java EE and all mobile, all this new stuff, different formats and protocols, and it gets really messy really fast. Now, what continuous integration, continuous delivery brings is a disciplined approach to getting changes promoted from your development laptop into production in a very consistent way, so that you don't end up with this. So it works great on my laptop, but when I get it into QA, now things are failing for unknown reasons. So, who's heard of DevOps? All right. So DevOps is this realization that IT is a differentiator for these companies, that it's no longer appropriate or a good business decision to outsource and treat IT as a cost center. The companies that are innovating, they're treating IT as a center of innovation, a differentiator. And by investing in IT, by investing in your developers and your operations and your infrastructure, and bringing in the discipline and the principles to refine things and eliminate bottlenecks and automate things where it makes sense, and for the purposes of being able to deliver your software faster and see whether or not the customers like your software or if it was the right software to build at that time, and to make that feedback loop really fast. So continuous delivery is a discipline. It's a practice. It's not. We'll show it something that makes it look kind of easy, but it's not just about the tooling. It's not a one-click button, which we'll show you in the demo. But it's a refining process. You start off small, and you start to automate little pieces, and you identify where the next bottlenecks are, and you try to automate those and put in processes there to streamline the path for making changes. So part of that is getting the right tools in place. And a lot of the times, the tools that you look at, whether it's open source or proprietary stuff, they weren't made to talk to each other either. They weren't really made to integrate very well either. So now you have an integration challenge at the enterprise app level, but then also how do you get the right tools together to help automate your systems? Now we'll talk about some of the tools, and we'll even we'll introduce Docker. We'll talk about Docker and what Docker brings to the table helps in the continuous delivery pipeline. And then we'll show how we're bringing these tools together for you and allowing you to change out the pieces that you need to, but we're bringing the tools together for you to form a CD, continuous integration and continuous delivery platform.
So now I will cover the part about the technology. So you already know that we need a collection of different applications, Nexus application, Jenkins application, and stuff like that. And you can imagine if you have yourself to set up those machines and those applications to put in place your DevOps environment, that will take times, that will cost a lot, and to simplify your life in a certain way. And that's the reason why today with OpenShift version 3, we are moving to this new world. And into this new world, the idea is that we will not spend anymore our time to put in place a collection of different operating systems on top of your machine. No, we will use a common operating system where we will deploy what we call an application, a small application, and this application, in fact, is using some specific key features coming from the Linux microkernel. From the Linux, they are using, by example, what is called C groups, what is called namespace. So the idea here is that we will isolate our different applications on top of an existing operating system instead of setting up different operating systems where I will deploy my Nexus application, my Jenkins application server, and stuff like that. And the technology that now we will use is called Docker. And Docker, the idea behind Docker is quite simple. And this is a container runtime. And this is where Docker daemon will communicate with the Linux kernel, like you can see on these pictures. What you will take and what you will do is that you will create what is called an image. And I will explain just after what is an image. Image will be published in a registry. So an image will be picked up from a registry, and the daemon will push from this image an application top of this operating system. So what is different when we are using Docker is that what you will deploy, which is called an application, a micro container or something like that, will be created from a collection of different images. So let's say you start a project. I need Ubuntu operating system. I need maybe a CentOS operating system. And to be able to deploy my Nexus environment, my Jenkins, and the other application, I need to install my JDK, my Java virtual machine. I need to also install Maven and different, let's say, tooling engine. And they will be packaged in an image. An image is something which is immutable. You cannot change the content of an image. And when Docker will build this small application top of this operating system, it will, from the registry, download a collection of different images. One will be your CentOS. The other will be maybe JDK, Maven, and stuff like that. And to tell to Docker how it should build this image, you will create what is called a Docker file. Within this Docker file, you will define a list of instructions. We have to start from CentOS. I would like to deploy maybe my JVM. I would like to download something. And during this building step, in fact, everything will be packaged in an image, which is a kind of zip tar file. And when it will be deployed by Docker on this unified file system, it will download a collection of different images. So in fact, what we have developed within this project, which is called Fabricate, we have designed a collection of prepackaged applications, which are in fact a collection of Docker images that we will use to deploy in a specific environment. Okay, this is cool to use Docker. I know that I will start, in fact, a process, and we will start a collection of different processes, but I need something else. I need to have the possibility to manage my collection of processes, which are, in fact, my collection of different applications. That's the reason why we need a new technology bricks, which is called Kubernetes. Kubernetes is a kind of operational management platform, and the responsibility of this environment will be to manage a collection of Docker container. Here is a Docker container, another one, and Kubernetes use, but that's a convention, that's part of their specification. They use this name, which is called a pod. A pod is a group of Docker-related container. They are packaged and deployed on a specific machine, which is a node, and that will be managed by Kubernetes. So Kubernetes has the possibility to install, deploy a collection of Docker containers, to manage them, to define using what is called a controller how many instances of an existing Docker container I would like to run within a node. He has also what is called a scheduler. This is where you will define the strategy about when you would like to start a specific container. And now we will discover some of the key features that we have also within Kubernetes. I have mentioned that we can create a pod, which is a group of related Docker container. Let's say I would like to deploy MySQL, I would like to deploy Wi-Fi JBoss CAP, but I need to communicate between my different applications. So we have the possibility within a pod which has been configured on a machine to have this cross-communication between the different processes. We can also, and this is important, we can also expose different port numbers because they are invisible internally, so we have to expose them externally. When we are playing with such kind of application, and we have also some time to share data, that means that we have to mount a volume. You can do that between your host machine and the internal Docker container. So all these possibilities, they are offered by the Kubernetes environment. And you can also create a kind of services, and not a kind. You can create a services. You can expose the services, and Kubernetes will have the possibility to load balance, to distribute the workload between your different pods, which are nothing more than a Docker, which is a process which has been started on top of this Linux kernel environment. And when you create a project, and when you create a Kubernetes project, you will design a file which is called a Kubernetes JSON file. And this is where you will describe how many instances you will need about your pods. You will define your different services. Here is an example where we would like to expose our HTTP web protocol using this port number. And based on this file, when we will deploy the application on top of Kubernetes, it will read this definition and set up for you the environment. And our technology is based on what we have here, but we have more, we need more, and this is what Christian now will explain.
So we'll be in, I don't know if we did already, but we will be announcing OpenShift V3, by the way. And the technology that we talk about today is going to be built on top of OpenShift V3. OpenShift V3 builds on top of Kubernetes, built on top of a Docker, but it brings networking. So when you have Kubernetes and Docker containers and you're throwing them out there onto nodes, they need to be able to talk with each other. You need to have services outside talk to those containers. So all the routing and networking and stuff between the nodes, OpenShift 3 will bring that. It'll bring developer-focused tools for self-servicing, pushing apps into Docker images, having your code automatically build and put into Docker images, and being able to trigger builds and so forth. So OpenShift will bring the developer-focused aspects to the paths, and sort of the enterprise stuff, the networking stuff that needs to happen under the covers when you're using Kubernetes. So OpenShift 3 brings the paths, the developer paths stuff to the table. And you can build your own orchestration for CI/CD on top of it. But this next project that I'll tell you about does that for you. So out of the box, it does a lot of the heavy lifting for bringing the right pieces together and having them talk to each other the right way to make it a lot easier to build up continuous delivery pipelines.
Christian, something that we forgot to mention is that OpenShift also proposed an additional services that we have not covered before. It's called OA2H. So you can't, using OpenShift, develop a solution where all the application will be, let's say, cross-authenticate using the technology which is embedded in OpenShift. And this is used by the technology that Christian will present now.
So Fabricate is that open source project that brings a lot of the CI/CD tooling and other stuff like logging and API management and that kind of stuff, but that's for a different talk. But so what it is a collection of, It's a layer that sits on top of OpenShift, on top of Kubernetes, that brings a web console for managing the apps that you deploy. It brings a set of pre-packaged applications that are designed to work together, for example, the CI/CD stuff, or the logging and monitoring stuff for Docker containers or Kubernetes nodes, API management. So it brings those things together and packages them up so that they behave kind of like, James Strachan likes to call it an appliance. Kind of, you just have it and you turn it on and you use it. There's also developer tooling aimed more at Java developers, though none of the stuff that I'm talking about is exclusively only for Java. It can be used for other technologies as well. But around Maven builds and working with Docker images and working with Kubernetes, the Fabricate brings Maven tooling to the picture. There's also Java libraries, which if you're going to extend parts of Fabricate, you can use. There's basically a Java Kubernetes client. There is etcd clients and all stuff for lower level, working with the underpinnings of Fabricate and OpenShift. There's also stuff in there related to dependency injection. So being able to inject Kubernetes services into your applications, being able to discover them in your code, so Archillion testing stuff. So there's a lot of stuff that comes in Fabricate, but we'll be talking specifically today about a set of prepackaged apps that allow you to do continuous integration and continuous delivery. Are there any questions about that? We're going kind of fast because I know we have the demo's going to take a little while. But are there any questions so far? Is it just, are we going too fast? All right. Excuse me. So among the developer tools I mentioned, Maven plugins, here's one. Actually, well, there's two of them. There's a Docker Maven plugin that allows you to, so Charles showed the Docker files for building images and doing all that. The Docker Maven plugin automates a lot of that stuff for you. So in your POM, you specify a base image, you specify ports, you specify volumes and that kind of stuff, and then the Maven plugin, when you do Docker build, will actually turn your project into a proper Docker image and build it using Docker.
And publish the image also in an existing registry.
The Fabricate plugins allow you, Charles also showed you the bunch of JSON that you have to write for deploying things to Kubernetes right now. The Fabricate plugin allows you to automate all that too. So again, you have a few properties and configurations in your Maven POM, and when you do Fabricate JSON, that will spit out OpenShift templates, or that will spit out Kubernetes JSON that you can then apply to OpenShift, and that act of applying the JSON will deploy your apps. That will trigger OpenShift to go download the images, pull the images, and install them, and configure them based on the replica controllers, or however many instances of the pods that you specify in your JSON configuration. So here's a visual overview of some of the apps that come out of the box. Hot.io, useful for managing the applications that are being deployed, visualizing what's in your Kubernetes environments, visualizing your camel routes and your ActiveMQ nodes and any of the other plugins that Hot.io brings to the table. It's built on Hot.io. And it also brings functionality for integration, functionality that we'll be talking about today. It brings API management and monitoring and centralized logging and centralized monitoring tools. Perfect.
So it's time now to have our demo.
Oh yeah, go.
I will first explain a scenario that now we will demonstrate. And we have created a page, and this page has been finalized yesterday. It is still under heavily development, so I will not explain the beginning of the process. I will start first and from the beginning, because the beginning of this page just explain how to set up the environment, to install everything. And we will start.
Which, by the way, we're simplifying. We're going to be simplifying that because you saw all the stuff that you have to do. We're going to simplify setting that up. And then we're going to merge all this stuff. So some of this stuff is in Fabricate. Some of this stuff we just wrote kind of yesterday. So we're going to be merging all this stuff back into Fabricate
project.
And making it, the setup stuff a lot easier.
In fact, to put in place this environment, we have created a Vagrant virtual machine, an image, which is prepackaged with OpenShift, with Docker. So we start from this environment that after that, Christian will demonstrate. And the entry point is next to be used, our Fabricate, out.io, a web console, and we will create a project. In fact, we will create our continuous delivery project from this web page. And when we will create a project, we will do a collection of different things. First, we will create our Git repository. So we have the possibility, because we have a collection of prepackaged applications, to use different Git applications. We support Gox, GitLab. Could be possible also very soon to be integrated with GitHub. But for our demonstration, we will use Gox. So here, typically, the first thing will be I will create a Git repo into my Gox repository. Next, we will also create a second Git repository under Garrett, which is a system which allows you to approve, to review, let's say to create a life cycle, a project life cycle between different reviewers. They will get the possibility to review the code, to accept, to reject, maybe to make some modification. And when we have decided, now we have something which is ready, now we have something we can move into the next phase of the pipeline, we will at that time use a pipeline into the Jenkins application. So at the beginning, we'll use this front-end environment to create a project. You will see, and that will be explained by Christian, that we can encode different information because we will start also to deploy into this Git repository a quick start, a demonstration that we will use for the purpose of this scenario. As I've mentioned, first thing, Git repository will be created, and the quick start, which is a Camel CDI example, will be imported into our Gox environment. Next, Christian will demonstrate that we will, using Garrett, create a small lifecycle, doing a Git clone of the project locally, doing a change with one of the files, commit the file into the Garrett system, somebody will approve, and when the approval will be done, and we will continue to the next phase, which is to use our Jenkins environment. In fact, at the same time that this project is created, that the different Docker applications are deployed and, let's say, started within the OpenShift environment, we also set up a Jenkins machine where a pipeline will be created. Until now, this pipeline has not been automated. Otherwise, Christian will click on a button and we will come back in 20 minutes. So for the purpose of this demonstration, we will interrupt the process and we will click ourselves on the run demo to see what are the next steps. And during the next step, we will compile the project locally. Our Docker Maven build will be called next to create also a Docker image. And when the Docker image will be ready, the code will be also published into the Nexus repository. Don't think that I put a slide here. It will be published in the Nexus repository. It will also use some of the script that we have here within the Garrett web frontend to approve a modification. We will see also that we have a replication between the Garrett repository and the Gox. In fact, we are using Garrett to approve a modification, a change, and everything approved will be visible under this Gox. Could be GitLab repository, could be also in the future GitHub. And next, we'll click on the button to start the pipeline process, which is created also with this first step of the project, first step of not the project, but first step of the process when we start from the Fabricate web console. The result will be published into the Nexus repository. And next, at the end, our Docker image will be deployed as a Docker application into the OpenShift environment. And we will have the possibility to access to our integration project, which is based on Camel technology, to see how we can monitor the content of our Camel environment. Everything is there. You can click on the button.
Now, it'll only
Cross
do
your
that.
fingers.
Yeah, it'll only do that if things don't go wrong.
If we have a problem, there is a backup. Christian this morning takes the time to record a video, so we have a backup in case we have some troubles.
Okay, so here's the OpenShift console. You see a few apps here, a few projects in here. What I did beforehand was deployed the Fabricate apps that I mentioned. I showed you the boxes. There's CI/CD and there's iPaaS and there's API management, all that stuff. I deployed the CI/CD app, which is, if you look on the Fabricate documentation, there's a continuous delivery section. The apps from there, basically, I installed those. Not really, there's some modifications I made, but it's kind of like that. Now, if I go to the Fabricate console, so when I install the app, it installs the Fabricate console, it installs Garrett, it installs Jenkins, it installs Nexus. Missing anything? It installs what we'll
Garrett,
find out right here.
Jenkins. No, we are not using others.
And the Fabricate console gives us a list, excuse me, a list of all the Kubernetes services. I can click to see a list of all the pods and the replication controllers. So we can make modifications to the replication controllers and scale up, scale down using the Kubernetes built-in replication controllers. But since we've deployed all of these little individual apps, let's look at them really quick. So Jenkins, you guys, I'm sure, have all seen Jenkins and know what Jenkins is. Same with Nexus, but Garrett. Okay, so all those apps came up. So far, so good. And
take the time to review. I will just quickly explain something. So for this project, we also took the time to develop some specific Docker image. So typically, by example, for the Garrett application, we also provide some variables, environment variables that you can use to define your administrator, your user, password. We have also created specific property to pass a collection of accounts that you can use to, in fact, pre-package the environment when the Docker container will be started. What we have done for Garrett, I can now continue, but I will not do that for Jenkins. So we have created specific variables which are used by Docker, but also when we create this famous JSON application configuration file. And for sure, in the future, we'll continue to improve what has been done to have the possibility to set up this project. And we are using this technology when we start to create a project from the Fabricate web console.
which is what we're going to do now. We're going to, within Fabricate, we're going to click on Projects over here and sign in. It already knows my username, so it's already signed in. And then we're going to click Create Project. Now what this is going to do, we're just going to create a Maven project, a Camel project. This is actually, under the covers, is going to use JBoss Forge. Who's heard of JBoss Forge? A set of developer tools for creating projects and managing projects. So we'll use JBoss Forge.
We are using a REST API to communicate.
There are some known little, okay, here we go.
Yeah, sometimes we have to refresh there is a JavaScript issue.
You guys can kind of see that? This text is a little bit small. So we'll create a project, we'll give it a package name. Basically what we're doing here is filling out the fields we need to populate a project from a Maven archetype. So we're going to use a Maven archetype using JBoss Forge, going to build our project. We'll call it.
Name of the project corresponds to the name of the Git repository that we will create, not ourselves, but this one click.
We'll pick the archetype from an archetype catalog, but you have these other options that you'll probably recognize if you've used JBoss Forge. So click that, click Execute. We're going to pick from the Fabricate set of archetypes that we have. We have auto-completion. We'll pick the camel CDI archetype. Fairly simple. We'll use CDI for injection, and it'll build a camel route. So if I click on execute, that should create our project. Woohoo!
Project has been created. We can have a look on Gogs, in Gogs.
We'll look at Gogs, yeah. We'll go to our Git hosting.
So
site.
we have a predefined user, which has been defined according to an env variable. And the project is created.
We see some activity here, and if I click over here, it created the Git repo for us. So we clicked on create project. It used the Forge tooling to build up a project, and then it pushed it into Gogs, which is the Git hosting choice that we've made, but that can be swapped out. You can use GitHub public or GitHub private or GitLab. So you can these pieces you can swap them out. You can enable parts of it or disable parts of it. If you go to the Fabricate documentation, there's also a set of containers, a set of services or apps that we have that integrates chat rooms and build notifications and issue trackers and also other stuff. But so you can enable and disable the pieces that you need or the pieces that you want. From Jenkins, we should see refresh.
Yes.
That it automatically generated our CI/CD pipeline.
We can have a look to Garrett.
We'll look at Garrett.
Website.
It built out the pipeline automatically. It uses the Jenkins DSL for that. Who's heard of the Jenkins job DSL? Yeah, it's awesome. On the Garrett side, projects list, it created our Garrett project for us that is now linked with the Gogs GitHub or Git hosting. So all the changes now, so it set up Jenkins, it set up Gogs, it set up Garrett for us. And all of the changes now, the process now for making changes to the system, making changes to this code, this project, is all changes go through Garrett. And they get code reviewed in Garrett. And nothing gets merged back into Gogs unless they've been approved code review. And the code review can be manual. You can have parts of it automated. You can have Jenkins do a quick build to sanity check before someone actually does any sort of review. And I guess the point there is when you're trying to do continuous integration, when you're trying to do CI and CD, you have to start off with continuous integration, and you have to do it right. And a lot of people start doing it, and they're like, the master branch keeps breaking all the time, people pushing crap to the master branch, and then they just sort of give up. What Garrett does is forcefully keep the master branch clean so that anything that gets through to Garrett has been reviewed and approved and so forth and builds and gets to the master branch. So let's check out the project. We'll check out the project here, and we'll make a change. Check it out, HTTP. Come over here. You guys can see that. So it's a basic Git clone, and we're going to make some changes to it. We're going to hook it up to Garrett, and then push the code up and watch the whole thing work. So here's our code, this basic Maven project. There's a tool out there called Git Review that will automate the integration. So we just checked it out from Gogs, right? You can use Git Review to hook it up to Garrett so that when you do a Git push, it'll push it to Garrett and not back to Gogs. And I wrote something.
In fact, here we have to add a specific identifier when we will send the commit to Garrett. And using this unique identifier, next, it will allow a different user to approve, to reject the modification. Starting at the beginning with an ID which has been created here by this tool.
Okay. So now it added our review remote. if I do make a change to something, now if I do git push review, this will create a new change set in Garrett, and it could email or send an alert to somebody that it needs to be reviewed. It could also have Jenkins automatically do a sanity build. So if we do that, yay, new change set. Hopefully, let's see. Click on my changes. Now we see our change made it into Garrett. So from here, we can use the Garrett tools to approve things, and I'm just going to give it a...
Click on the reply button so we can explain a little bit that we have different levels. No? All right. So in fact, we have different... Garrett define different values to accept, reject. So we have every time the possibility to use one of the values which is defined there and to propose a response, a reason why you have accept or you have reject the modification. For this demonstration, we will simplify our life and click on the +2 level corresponding to accept, approve. We continue.
Approve it. Now before I submit it, I just want to come over here and show you that this stuff is, so I did refresh. We committed it to Garrett, but it's not, it's still in a change set phase. It's not actually merged into the master branch on GOGS. So when I click submit, what should happen now is it gets merged into Garrett, and now Garrett's going to replicate the changes over to GOGS. So that means GOGS is kind of a read-only repository. You don't push directly to it. All changes go through this process. Now, this is an illustration of the CI step, the continuous integration step that you could use. You don't have to use it. It's just and there's different ways to set up your continuous delivery pipelines as well. These are just examples, right? This is not the way you do CI and CD. So if we come back here, do a refresh.
And of course, the replication between Garrett and GOGS is a parameter that you can define when you install, deploy the different application top of OpenShift.
So we can see the change made it through, and I didn't. So I turned the webhooks off on the delivery pipeline, but you can turn that when you turn that on, and it's on by default with when you install this app from Fabricate. This will kick off a build in Jenkins, which I'll do manually right now. So we created the project with Forge. All of the Garrett, GOGS, Jenkins stuff was automatically set up. We made a change, reviewed it, and now we're kicking off the build pipeline. So now what this first step is going to do, the CI step, is build the project, run the unit tests, and if everything looks good, it's going to promote it to the next stage, which in this case would be integration tests or whatever you would specify in your pipeline. The idea with continuous delivery is that when you do a build and it works, and you promote it to the next stage, then you continue to promote it until some step fails or it makes it into production. But to do that, you're not going to be pushing snapshot builds into production, so you give it a tag, you give it a version up front. So in this case, what we're doing is we're giving it a new version based on whatever the build number is, and we push that into Nexus, we tag it, and then we promote it along the next steps in the pipeline.
It takes time because he has to download a lot of artifacts from an external Maven repository, and this is what we can see on the console output.
So it's still working. What it's going to do next then is, if this works, is going to go to the integration test phase. And what that does is, Fabricate has Archillion plugins for doing your tests in Archillion, but in a live Kubernetes OpenShift environment. So you write your integration tests, and when you deploy it using, or you write it with the Fabricate Archillion plugin, what it'll do is actually spin up in a new Docker image, in a new project that was created on the fly inside of OpenShift. It'll deploy it, run the integration tests, and then tear that stuff back down. So on the fly, it's able to provision the resources it needs and deploy your project. And using the Kubernetes Archelion plugin, you can then exercise your tests at that point, and it'll all spin back down. Come back to the pipeline. We see that built. So now that the CI step is done, we should see in Nexus that we have an artifact that was built and given a version, yes. 1.0.1. It was automatically tagged in GOGS. So we can always go back to that build and the code that was associated with that artifact. In this step, give it a refresh. Yay. And then, so the next step after integration testing is to actually deploy it into the Kubernetes environment, to the OpenShift environment. And what this step does is build the Docker image, apply it to Kubernetes in a new project, or Kubernetes uses namespaces to isolate sets of pods. So with pods are a collection of Docker containers like Charles mentioned. And within pods, you can discover other pods or services. And you discover them by reading environment variables that are automatically injected into the pod. Now, if you deploy services that are not meant or should not be discovered by certain apps, you can isolate them into individual namespaces so that they can see only what's in the services that are inside that one namespace. For a CI and CD pipeline, you could have a namespace for dev, a namespace for QA, a namespace for prod mirror, and conceivably prod. You'd probably separate out the Kubernetes environments from your lower level environments and what actually runs in production. But what gets promoted between the environments is the Docker images. The Docker images that we built, those, without being touched, so they're immutable at that point, they don't change. Those get promoted from one environment to the next, and any of the environment-specific details of like what database an app connects to or what services it's supposed to discover and talk to, that's all injected by Kubernetes using environment variables. So in this case, what we did was build our microservice app here and build the Docker image and then deploy it into the development namespace. So yes. if we look at that, let's come back to Fabricate console, repositories. We can see our repository was built here inside of Kubernetes. We're going to switch to so here's the different namespaces that we created. We'll switch to development, and it takes a second. I know there's a bug that's in this. It'll take a second, but it should be there. We can also prove it by coming over here. And we see the app that we deployed using the pipeline was deployed into the development namespace. If I remove that, it's not in the default namespace. So it was correctly put in the right spot. Anything that you want to say?
Do you think that it will be there soon, or?
Give it a second. There's a WebSocket bug that it has, but it'll show up. Are there any questions?